Hi, this video is going to be about AWS Serverless and how we should go about developing AWS Serverless solutions. And one use case which I'm going to present in this video is a scalable chess match results prediction application. So the use case goes something like this, where suppose a chess match is about to happen. So what users can do is come on this platform and they can participate in this contest where they will answer 4 5 questions. Each question will have a binary answers like yes or no or this or that. And once they select all the answers to the question, then like there are just 5 questions, right? So and each has two answers, so there are limited number of combinations that can be generated. So each combination will have a selection id. So like this way, selection id will be generated in front end, and the contest id is nothing but the chess match that is about to happen. So then we will just capture these responses and then store them into the DynamoDB table. And then after the match is finished, then we will do reward dispatching. So once we will get match results, at that time we will fetch all the users who have won that contest by selecting that particular selection ID, which actually got all the answers right. And then we will email them telling them, okay, like you have won the contest and these are your rewards or gift cards, something like that. So basically here there are two main concerns: capturing user responses and dispatching the rewards. So let's get started. Here, doing this in a normal way is not an like challenge, but doing this at scale for like let's say 10 million users is the main challenge, is the tricky part. So let's see. So here are our two concerns. First thing, capturing user responses, and there will be huge concurrent users, and then dispatching reward after receiving the match results. Capturing user responses can be taken care with ECS service with an ALB. So this setup is actually quite battle tested, and it works flawlessly, where you will just have one route 53, then it will forward request to ALB, and ALB will forward to ECS tasks, which will run an SJS service to capture all the user responses. And dispatching user rewards is another concern, where suppose like you need to bulk retrieve the records in parallel way and then process and dispatch rewards in parallel. So this is a huge database, and where there is all the selection users with selection IDs and then give them rewards, and we need to do this on all in parallel way. So let's see like how we should go about doing this. So like I mentioned earlier, capturing user responses is pretty much straightforward, and we will use this setup where suppose user clicks on submit prediction, then a post request will happen. It will go to route 53, and route 53 will like resolve the DNS, and ALB, the request will go to the ALB, and then ALB will do the load balancing. ALB application load balancer will do the load balancing between ECS tasks of our ECS Fargate service. So ECS tasks, so let's say there are 5 million users currently. This will get scaled horizontally, and we will have like let's what like 30 50 tasks as required. And then eventually each task is running like Nest.js service, and this Nest.js service will just accept the request, do the JWT validation, or do API debouncing. And then what it will do, that it will process the request and do some business logic, and eventually the request will land up in Amazon AWS, Amazon DynamoDB. And here we can configure the ALB to an ALB and ECS service to be in multiple availability zones to like really handle the load. And also we can configure AWS DynamoDB's write capacity units. We can also keep them dynamic, but we can also provision them beforehand to handle the huge load. So is actually this setup has proven itself in many cases till now. So a lot of companies use this setup. They'll just put this setup and can handle all incoming requests. Let's look at our DynamoDB, how it will look like. So now, like this is the first version of the setup. For reward dispatching, we will change it a little bit. So here the first setup would look like something like partition ID sort key, simple. partition ID will be contest ID, sort key will be user ID, and incoming request would look like, okay, for this chess contest, for this user, he has selected this selection ID. So like this, will be storing all the records in DynamoDB. And then let's jump to the interesting part, reward dispatching, how it will work. So if you, if theoretically speaking, if we want to give rewards to all the users who have won the contest, okay, what we need to do in a nutshell is get all the records where contest ID is equal to xyz, or whatever contest ID that is just finished, and selection ID, the we will search for the winning selection ID, get all the records, and then for all those records dispatch rewards, means like just give them a gift code or something. So for 10 million records, we are talking about roughly about 2 GB of data. And then you can't just load this 2 GB of data in your Lambda's memory and hope it to work. And Lambda also has a 15 minutes hard limit. So this is easier said than done. We need to follow some different approach. So we'll be using partitioning to divide the table into the multiple partitions and treat them separately and in a parallel way. So we are following divide by introducing partitioning. So let's see how we'll do it. So while inserting the record into DynamoDB table, what we will do that for each record while insertion, we will while doing insertion, we will assign a partition ID to each record, and this partition ID value will be from 0 to 9. So and we will do this by using some hash function. So we will run this user ID through some hash function, and then it will give a partition ID. So like this way, the whole database will be divided into 10 partitions from 0 to 9. So each record will belong to one partition. So each record across multiple contest and multiple selection IDs. So like there will be will be different users selecting same selection ID, and there will be different users in multiple contest. So all this will be spread across 10 partitions from 0 to 9. So our new database would look something like this, where earlier we had partition key which as a contest ID and sort key that will remain same, but here we are introducing one new global secondary index. So global secondary index has a partition key as contest ID, and then a sort key as a selection partition ID. So selection partition ID is where, if you see, our new record would look a new record in DynamoDB would look something like this, where like we usually have user ID, selection ID and contest ID will remain same as earlier, but here we have new partition ID and selection partition ID. Selection partition ID we are keeping it sort key, and we are introducing this new composite key because we want fast AWS record retrieval by using indexing. So with this index, it will be very fast and efficient compared to scan, or then compared to getting the whole partition and then filtering it in memory. So this is very much perfect for this use case. So here what we are doing, we are getting all the winning selection IDs for a contest in a particular partition using a composite key, like that way. So our database would look something like this, where there are records for multiple contest XYZ and context XYZ2, and here there will be multiple users 1 2 3 4 5 6 7 8, and then each might have selected selection ID 1, selection ID 2, and there will be different users in another contest, obviously. So selection ID 3, etc, etc, and then each record will be in which record will be assigned one partition ID, which will be like 2 3 4 5 2 2 2 3. So like this. So suppose winning selection ID is selection 3. So our whole database is divided into partitions. So here what we will do, we will spin up in parallel 9 lambdas, and each lambda fetching that particular partition from, like, so let's say this lambda is fetching all the records from partition 2. This lambda is fetching all the records from partition 3, and this lambda is fetching all the records from partition 4. Like this way, 10 lambdas will in parallel fetch the records from that partition, and then they will package them, into the batches of 80, and this will happen in a stream way, so that it will keep freeing up the memory as soon as the 80 records had been dispatched to this batch processor Lambda. So batch processor Lambda, what it will do, it will just, whenever it receives 80 records from the partition processor Lambda, it will for those 80 records from our internal other service, will get a gift card or whatever user reward that we want to give for this winning user. We will package them, and then we will send them an email. So let's say our Lambda can process roughly about 80 users in 15-minute limit. So like this way, there will be 10 partition processor Lambdas running in parallel from 0 to 9 partitions, each Lambda fetching up that partition users in partition and then dispatching the rewards like this. So here, so this is like roughly how it will work. This is like this: 0 1 2 3 4 5 6 7 9 till 9 different Lambdas. This Lambda's job is solely just fetching the DynamoDB records and then giving the and then triggering new batch processor Lambda for each batch of 80 records. So let's look at the reward dispatcher step function. So here what will happen, whenever after the chess match is finished, we will receive an event in this SQS queue having the contest ID and winning selection ID. Then what it will do, this Lambda will get triggered, and this Lambda will trigger this state machine. In state machine, we have the first step called initialize partition, which will initialize an array from 0 to 9. And for each element in array, it will trigger this partition processor Lambda. So what will happen in partition processor Lambda is in input we'll get contest ID, winning selection ID, and partition ID. So then what it will do, it will trigger all the records from this partition using the contest ID and winning selection ID using the index selection partition index. If you see here, we are using the composite key, winning selection ID, hash, partition ID. And the next step would be accumulating this records into an array. And when array size reaches 80, then what we will do is we will dispatch this batch to this other Lambda, which is reward dispatcher Lambda, which is indeed responsible for actually processing the records, making the other service API call and getting the redeem code or anything like that, like what we want to give the user, and then sending an email to that winner user that okay, this is your reward. So how it will look like is like I mentioned earlier, like this. In state machine will get triggered, we will map the partitions from 0 to 9, and from 0 to 9 partition processor will and Lambda will get triggered, and each partition processor Lambda will then trigger subsequent batch processor Lambda for batches of 80. So like this way, in a parallel way, we are processing all the records from a partition and for a contest. So yeah, this is it. Thank you.